The secret to the whole EV revolution, it isn't just about bigger batteries or cool, sleek designs. Turns out, it's about a tiny, incredibly powerful component working its magic behind the scenes. And today, we're finally putting it in the spotlight.
So here's the big question, right? How do you unlock more range and get faster charging? It all comes down to managing the immense electrical power inside an EV way more efficiently. And the answer? It lies in a special kind of chip. A chip that's changing the entire game for electric cars.
Okay, so here's our game plan. First, we'll meet our unsung hero. Then we'll see why the old standby, silicon, is really hitting its limits. We'll introduce the next-gen challengers, see how they're totally revamping the heart of an EV, and check out the shockwaves they're sending through the market. And finally, we'll get a peek at the future this tech is building. All right, first things first. Let's get properly introduced to our main character today, the power semiconductor. You can think of it as the brain and the muscle of pretty much any modern electrical system. Now, don't confuse these with the memory or processor chips in your computer. Those are all about data. These guys, they're about raw power. Their job is to take electricity from a source, like your EV's battery, and shape it, convert it, and deliver it with the perfect voltage and current that something like a motor needs to work. The best way to think about them is as these incredibly smart, incredibly fast traffic cops for electricity. They're directing power, converting it from DC to AC, stepping voltage up or down, and making sure not a single drop of energy is wasted. In our electrified world, preventing power loss is everything, which makes these tiny little chips absolutely essential. For decades, one single material has ruled the world of electronics. But you put it in the intense, demanding environment of an electric car, and well, it's starting to show its age. And look, silicon has been a fantastic workhorse. It's cheap, it's everywhere, and we are masters at making things out of it. But the sheer amount of power that flows through an EV, especially when you floor it or plug into a supercharger, it pushes silicon right to its breaking point. The biggest problem with silicon is that it's just inefficient. When you push a lot of power through it, it wastes a huge amount of that energy as heat. Get it up to around 175 degrees Celsius, and its performance just falls off a cliff. To deal with that heat, car makers have to install these big, heavy, complicated cooling systems, which adds weight, costs money, and ultimately, it hurts your range. So if silicon is hitting a wall, what's next? Well, two new materials are stepping up to the plate, ready to solve all of these problems. So let's meet the next generation of power semiconductors. And the difference is just staggering. I mean, just look at these numbers. SiC and GaN have something called a bandgap. Think of it as their electrical toughness. That's 3 times wider than silicon's. That lets them handle way higher temperatures and voltages. And their breakdown field, it's over 10 times higher. That means you can build smaller, more powerful components. And check out SiC. It's 3 times better at getting rid of heat. They're just playing at a totally different league. But they're not interchangeable. Think of them like 2 different kinds of athletes. Silicon Carbide, or SiC, that's your marathon runner. It's incredibly durable, built for the punishing, high-voltage, high-power work inside an EV's main drivetrain. Gallium Nitride, or GaN, that's your sprinter. It's ridiculously fast and efficient, which makes it perfect for things that need to switch on and off at super high frequencies like 5G radios or those little powerful fast chargers for your phone. Okay, so let's bring this all back to our first question. We've got these incredible new materials, but how do they actually make an electric car better? So inside every single EV, you've got 3 critical power systems. The main inverter is the real heart of the drivetrain. It's what takes DC power from the battery and turns it into AC power for the motors. Then you've got the onboard charger for when you plug into a regular outlet. And finally, a DC to DC converter that powers all the normal stuff, like your lights and touchscreen. Each one of these is a prime spot for these next-gen chips to work their magic. And the results are just wow. By simply swapping out old silicon chips for new silicon carbide ones in that main inverter, you can boost the entire vehicle's energy efficiency by up to 10%. That is a massive, massive leap from changing just one component. So where does that huge 10% gain come from? A huge part of it is by cutting down something called dynamic power loss. That's the tiny bit of energy that gets wasted every single time a chip switches on and off. SiC modules slash that waste by an incredible 80% compared to silicon, and less wasted energy means more power going to the wheels. So what does all this techie stuff mean for you, the driver? It's actually really simple.
It means longer range because you're squeezing every last mile out of your battery. It means faster charging because SiC can handle the high voltage systems you need for that. It means lighter cars because you don't need as much cooling hardware. And kind of surprisingly, it can even lead to lower costs because a more efficient car can get away with a smaller, cheaper battery.
Now, a technology this disruptive doesn't just change the engineering diagrams, it completely reshapes the entire market. Let's take a look at the money side of things. What you're looking at here is nothing short of explosive growth. The market for these advanced semiconductors, your SiCs and your GaNs, is set to skyrocket from under $1 billion in 2020 to over $5 billion by the end of the decade. That is a crystal clear signal that the entire industry is betting big on this shift. Okay, so you might be thinking, if these chips are so much better, they must be way more expensive, right? And chip for chip, you'd be correct. But that's not the whole story. The real economic magic happens when you look at the whole system. The money you save on smaller cooling systems, less copper wiring, and most importantly, a smaller battery pack, it more than pays for the higher cost of the chip itself. And just think about that for a second. The battery is by far the single most expensive part of any EV. So if a more efficient chip lets you shrink that battery by just 5 or 10%, boom, you've just created a massive cost saving for the whole vehicle. This isn't just a performance upgrade, it's an economic revolution. And this revolution in how we manage power goes way, way beyond the highway. It's actually building a more efficient future for all of us. The exact same principles, better efficiency, more power in a smaller space, are transforming other critical industries. The inverters in solar and wind farms, the power supplies for giant data centers, the motors inside industrial robots and high-speed trains, even the base stations for our 5G networks. They're all getting a huge boost from this leap in power semiconductor tech. So when you boil it all down, what we're talking about is a truly foundational shift. This isn't just about making the things we already have a little bit better. It's about enabling entirely new technologies by smashing through the old limits on power management. It's the key that makes a truly electrified future not just a dream, but a practical, efficient reality. So that leaves us with one final big question. We've seen these chips completely change EVs, renewable energy, and communications. As they get even more powerful and more efficient, what's next? Are we talking about electric aviation, super intelligent power grids? The potential seems almost limitless. The race to perfectly manage power is on, and these tiny chips are leading the charge.